through the BMS if it's all integrated properly. Okay, let's just start quite simple, okay? If we've just got a standard single heat pump installation with a WPM and a single heating circuit. Now, this probably suits, more than 50% of the installations we're seeing. Obviously we do a lot of cascaded jobs with multiple heating circuits, but in the case of it's just one heating circuit and it goes to a buffer tank, the WPM can, if so be chosen, can effectively just manage the buffer tank. And then somebody can have whatever comes out of the buffer tank can be controlled by a third-party system. Now, there's all sorts of third-party systems, your Nests and your everything else, and everybody's got their favorite. And what people want to know is, A, can it be done, and how do we integrate it? So it is very, very simple, okay? I'll just close a couple of windows here. It is very, very simple. What we do, and this is basically, we've done this based on an Auspex manifold actuator system, but it is the same, whether it's, it's an Uponor, it's an Auspex, Rehau. And the reason it's the same is because most of those manifold systems have got a dry contact, which is just used to initiate the boiler. So if you've got a Rehau system and you've got a gas boiler outside, basically all the manifold system is doing is closing a set of contacts, which gives the boiler a signal to go. So if we want to do this in an exceptionally basic configuration, on the WPM, I don't think I'll have to go too much into explaining things because everyone I'm seeing in these, everyone seems to be staying the course. We've got this X113 terminal, okay? X113, if we go into the commissioning on the WPM, we can go into the commissioning menu and we can go into what's called the IO configuration. I'll actually do it in a minute and actually show you guys. And we can say, we want that terminal there, X113, to act as an off-on switch. And all we have to do is then link 2 and 3, and the system will turn from standby mode into programmed operation. Or it'll turn from eco mode into programmed operation. We'll do either or. So for someone who just wants to do the most basic operation and wants to, instead of putting one of our FETs on, wants to put a Siemens wall controller. Now that may be the case because the customer's upgrading from an existing boiler system. They've had the same controller for the last 10 years and they know how to use it. So they've asked, can we just have the same controller? It's already programmed up. We just want it to work exactly the same and not know the difference. Yeah, you can effectively do that. Very simple. Just run what would be the boiler twin, the figure 8 or whatever's being run. Just run it to X113 and set the program and away the thing will go. So when the thermostat makes, it says on, it just turns the system from standby to programmed operation, which is on, and and vice versa. When the thermostat reaches temperature, it just turns the unit off. There's a lot of systems set up like that. I will be going into further in the actual, when I'm doing the heat curve presentation, and I'm talking about heat curves and flow temperatures and efficiencies. I will go into some detail with some slides and some evidence about, in fact, why that is not the best setup. We can do it. You can do a third-party stat, but I'll be able to show you why it is, in fact, better to stick with the FETs and the systems we have available to us already, because we've done a lot of the thinking, we've done the design about how to maximize the efficiency out of the unit. So we will be talking a lot more about that in the heat curve presentation. But you want to do it, you can do it. So you can have the heat pump hitting the buffer tank, like I've mentioned, and you can have coming out of the buffer tank, you can have it running into a manifold if you so like, and you can have 5 heating circuits, all controlled by thermostats dotted around somebody's house. The thermostats can control the pumps and then have a signal back to the WPM to start our system. Very simple, can be done. Okay, let's talk about the next level of control. Okay, and in fact, what we might do, we might just jump ahead and we might look at not using a third party, and we might look at what we can do when we're just using our heat circuit control system. Okay, so I've showed this slide quite a number of times before, and probably I'm repeating myself through presentations, but you know, we're trying to make sure everybody's 100% across it. If you have a WPM, you can control up to 3 heating circuit pumps, 2 of those being mixed. Okay, so 3 heating circuit pumps, 2.3 will be the unmixed circuit because there's no mixer attached to it. There's no even terminals for a mixer for heating circuit 1. Heating circuit 2, a pump and its corresponding mixer. Heating circuit 3 and its corresponding mixer. Okay, let's just talk heating for a moment. If we just have a heating system, we can, if we so wish, set up those circuits running purely on the heat curve. Now, I'll go into heat curves and so on, as I said, in another module. But what that means is we're using the ambient sensor, which we put into X1.3, and we're saying we're making determination based on the temperature outside, how hot to run these circuits, okay? A heating circuit number 1, being straight out of the tank and not mixed, would always be your hottest circuit, okay? So if you're going to do radiators, you put them into heating circuit 1. If you're going to do underfloor, you put them into heating circuit 2 and 3, okay? Not the other way around, because heating circuit 1 basically is straight out of the buffer tank. So if you're doing radiators and underfloor heating, you'd come straight out of the buffer tank with the hottest water to do your radiators, and obviously then you'd mix down to do your heating circuit. So what we do, you know, we've covered this before, but we put sensors obviously on the heating circuits so we can measure what is going to 2 and 3. And then what we'd do, I'll just swap screens. We'd go into our each heating circuit. This is just the navigator. I hope that's come up for everybody. And we'd go into settings and we'd go heating, and we would look at each individual heating circuit. I'm just going to turn on another heating circuit here if I can. Underfloor heating, radiators and underfloor heating. Okay, let's see if we've got 2 heating circuits here. We've got heating circuit number 1 and heating circuit number 2. Okay, this is, so we could, if we wish, just set up these heating circuits, which are just pump controlled, remember? So we're not controlling actuators with our heating circuits, we're purely controlling pumps, okay? So heating circuit 1 might be our radiators, and we can set our comfort temperature and our eco temperature. We'd set our minimum temperature if we wanted a minimum temperature for a particular application. And we can set our heating curve. Now, like I said, we'll cover that more a little bit later, but heating curve is the relationship between the outdoor temperature and what we want the buffer temperature to be. So the higher the heating curve, the higher number on the heating curve means that we want, you know, if we look at a temperature of say 10 degree ambient and we set a higher heating curve, we will have a higher buffer temperature with a higher heating curve set point, okay? And if we have a very high performing house, we may have a lower heating curve, meaning that we are generally speaking running a lower buffer tank temperature for more efficiency. So we can set up heating circuit 1 with its comfort temperature, its eco temperature, minimum temperature, and its heating curve rise. Easy. Let's pop back into heating circuit 2. Heating circuit 2, remember, is the first of our mixed circuits. So because we have a mixer on this circuit now, we can set our comfort temperature and eco temperature. So comfort temperature might be a daytime / evening temperature, and eco temperature might be overnight. And then we use the program to jump between them. Having a mixer now, all of a sudden we can set up a maximum temperature. We can set up a mixer dynamics, meaning that that's the speed which the mixer is operating. So we can use, you know, other mixers that aren't necessarily supplied by, in our standard product range. And once again, we can set a particular heating curve for heating circuit number 2. Now, we can keep going there. We can keep expanding on that. So heating circuit 3, heating circuit 4, heating circuit 5. If we want settings, heating, now heating circuit 1, 2, 3, 4, 5. So what, that could be? That could be heating circuit 1, obviously straight out of the buffer tank. That could be some upstairs radiators. Heating circuit 2 could be the master bedroom suite, 3 living, 4 guest wing, heating circuit 5, whatever. all pump control. So the difference between having all pump controlled and obviously manifold control with actuators. Okay, when we're bringing off and on a pump, particularly if we're using a mixer. With a mixer, we like to run the water all the time. We like the pump to keep going. Now, people say, isn't that inefficient? So on. It isn't. In fact, all the data we can provide can show you that the difference between running the water through the slab all the time and just changing the temperature versus running a fixed temperature and turning it off and on, the difference can be staggering. As far as A, comfort in the house, and B, the actual power usage. So we can achieve better comfort with lower power usage by running mixers and running the water through all the time and just adjusting the temperature of that water. You get less problems with overheat and you get less problems with, the temperature outside plummeting. Could be a 2-hour lag until the temperature inside goes down, and then the pump has to turn on to then reheat the slab to try and catch up for that temperature drop happening inside. It's quite interesting. It's quite interesting when you actually start looking at the data. So if we're just doing a heating system, we could, if we want, have no controllers inside the house at all. No controllers. And we can just look at each individual circuit and we can set them all up on their individual heat curve. And that way we're just adjusting the temperature going to that heating circuit based on whatever's happening outside with the temperature. Now, you may ask a very sensible question. How can you set an indoor temperature then? If there is no indoor temperature sensor, how does it know? It's doing a calculation. That's all it is. So we're telling it 20-degree indoor temperature is what we're aiming for. We're saying a heat curve of this. We're setting in some of the bits and pieces. It takes a little bit of fiddling to get right. Not much though, once you know how to do it. And basically that customer can expect a very, very constant temperature through their house because it's basically running on a weather dependent mode. It's an excellent way to set it up. If you don't want to use controllers inside, you don't have to use controllers inside. However, if you so wish, you can put, I'll just jump back to my other screen. If you so wish, you can take each one of those circuits to 3, 4 of your mixed and your direct one, which would be over here if you're using a direct circuit. You can put an FET on those if you wish. You don't have to. You can have an FET on 2 of the circuits. So the main living, you could put an FET on so they can see the temperature in there and so on. And the other circuits can, if you wish, can just be controlled running off heat curve, completely weather dependent mode. Okay. So how the weather dependent mode also works. You can set in a function called summer mode. I might even just show you. I'll just jump back to the other one. So you can set up in settings a function called summer mode, where we basically just look at the outside temperature and we could say, all right, let's turn the heating off once it hits 20 degrees. And the building heat buffer means once it's hit 20 degrees for 1 day. So it has to average over 20 degrees for 1 day. So in their most simplistic way, just using stable control only running from the WPM, you could have a system with 1 manifold underfloor heating, no controller in the house at all, and you could have the temperature outside starting to drops below 20 degrees. The unit says, all right, it's 20 degrees, it's getting below 20 degrees, let's start up. Away it starts, and then the temperature starts dropping more and more and more, and it says, righto, it's getting colder and colder outside, let's start lifting our temperature. And it could run purely on a full automated weather dependent mode. Very, very simple. A lot of people set them up like that. A lot of European homes are set up in that manner because the Europeans don't have this zoning obsession that we have here in Australia. I mean, that's come from the ducted industry, and a lot of the technology evolving around ducted systems is the ability, okay, now we can zone it all down to one room. It might be, be particularly effective nor efficient, but you can do it. And people want those features because they think they're getting an upsell. A lot of the time, the zoning complicates a hydronic system and doesn't necessarily, because of the lag and the subtlety of the heat and the time it takes to get that heat, and you want to warm the building and keep it warm, zoning isn't as much of a factor. Well, shouldn't be as much of a factor, but there is people that still demand it. So that's why we're saying you have the option. If you want to run on a stable control system, you can, and it's heating only, you can choose to put FET inside or not. If you don't, obviously it just runs on the outdoor. If you put an FET inside, then in fact, we can go to that individual circuit. Let's have a look at heating circuit 1. It's not giving us because this is only a simulation, but normally it would say something along the lines of room influence. And you can actually say what bias you want to give the controller between indoor and outdoor control. So you can say, I want it to run purely on its outdoor sensor. And you can say, then there you go, 0% room influence. Or I want it to run 100% on its indoor sensor, 100%, or everywhere in between. So we do take a lot of influence and a lot of our running, what's the word I'm looking for? A lot of our running data from our outdoor sensor. It makes a big difference to how we operate our systems. And it makes a difference significantly for the better. So the old notion of just having an on-off thermostat, we'll go into it in a second and we'll have a little bit more of a look at differences between doing that and doing it sort of the way we do it. Okay, I'll just jump back to the other one. Okay, now, if we are doing cooling, cooling becomes another matter. If we are doing cooling, we want to run potentially cold water through our circuits, okay? Or if we are doing a direct pump set off our buffer tank, we may want to run fan coil units, okay? So with cooling, any circuit you set up for cooling must have an FET. So firstly, you will not even be able to get access to a menu for cooling for that particular circuit without having an FET. So it's very important. Now, once we are into cooling, I'll just see if I can bring that up on the navigator again. Let's see, we got cooling here. Heating or cool, here we go. Hot water. So let's just go back into the menu. Actually, I tried to do this yesterday and it doesn't show it particularly well with the cooling. Distribution system, we've got, let's go cooling. Sorry, active cooling, there we go. Okay, once we bring up cooling and we've got the flow sensor in place and the FET in place and we've got a reverse cycle unit, we will have the ability to go into a cooling menu. Now, you'll note, with cooling, we have two options how we want to cool a particular circuit. And we can turn off cooling, we can turn on and off cooling per circuit. So if you've got a job where you've got upstairs radiators, you've got two sections of underfloor heating, and you've got fan coil units, you're going to have 4 circuits, obviously, in that sense. So we can look at circuit by circuit. You can say circuit number 1 will be the radiators. Let's turn cooling off on the radiators. We don't need cooling on the radiators. They're not there to cool. Circuit 2, however, could be our underfloor main living area. So let's turn it on. Now, we have 2 types of cooling to choose from, okay? And that is area cooling. Let's just throw a code in here. You have area cooling. Does that give me the option to change it? Or we have fan coil. Okay. The difference between these two types of cooling is fan cooling is a fixed temperature cooling. Okay, so if I was to put that, I might do it, if I was to put that back on fan type cooling, set flow temperature, that's it. It's fixed temperature, and we can set that temperature down as low as we can possibly go, because that's what temperature we want to send to our fan coil units. Okay, now fan coil units, remembering, have got drains, the condensate drains. So they're picking up the condensation formed inside the unit and out the drain. If you're doing 7-degree flow temperature to any fan coil unit, you'll have to remember it's below the dew point. So all of your insulation, all of your pipe work has to be insulated and has to be able to withstand any sweating and so on. So you have to do all your joins, you have to insulate elbows, all of those things, because moisture can be a real problem. Obviously, if you've got a pipe set running across the ceiling and you've got gaps in your insulation, it's going to drip in that spot. You're going to get stains on the ceiling and so on. So we can set the fan coil units, being our cooling circuit 2, to fan coil mode. Let's go back one. Circuit 3 may be our underfloor area. So cooling type, we want area cooling. So area, as soon as you put on area cooling, all of a sudden that cooling circuit will enter dew point management mode. Okay, you don't have to set anything else for that. It just that's the function that it's in, dew point manage mode. So you can change it cooling circuit by cooling circuit, which mode that that circuit is in. So dew point manage mode means that the FET that's installed in that circuit, don't forget the FET would have to be inside the conditioned space. I know some people want to put FETs in cupboards and in laundries out the back or something like that. But if you're trying to do a dew point measurement, the FET needs to be in the conditioned space. The FET will measure the humidity, the FET will measure the room temperature, and the FET will make a dew point calculation. Then the water will be, the set point for the water will be 2 degrees above the dew point. So for example, we're looking for mixed circuits here. That's a fan coil unit, radiators and 2 of underfloor. The fan coil unit obviously can be set for fixed temperature, 7 degrees. The radiators can be turned off and the 2 underfloor can be run on dew point managed mode. So we can select the mode per heating/cooling circuit. Okay. Now, obviously important to remember, a WPM can do 1 direct circuit and 2 mixers, and the WPE, which is the heat pump module, the heat pump manager extension, can do another 2 mixed circuits. So we can effectively do 5 circuits altogether, all pump controlled. You can choose whether they have an FET or not, based on whether they're heating or cooling or you feel you need it. You can choose whether it's an active, it's a fan, like a fan temperature cooling, fan coil temperature cooling, but a fixed temperature of 7 degrees or 10 degrees, and you can choose whether you want it to run it on dew point managed mode. Now, I know when I was down in Melbourne a while back doing a lot of commissionings with Dietmar, who people remember Dietmar, the German fella who came over, we in fact were setting up units on radiators, and we thought, oh, well, the unit can do it anyway. Everything's there. Let's just pop it onto dew point managed mode anyway for fun. And, you've got a 15 kilowatt heating system where the coils, you put dew point managed radiators, it's going to cool the radiators, and you might get 1.5 to 2 kilowatts or something out of them. It's very, very low. I wouldn't be selling any units in that manner as a cooling system, but you can do it. And you can do it because the system's already set up to do it. So if you've got a system that's just an underfloor heating, like this, could be very simple. There's the heat pump, there's the buffer tank, and there's the pump set going out to the room, just a manifold. And you want to set it up on the cooling. All we need is the cooling sensor and make sure there's an FET in place. That's it. And you just go bang, pop it on the dew point managed mode in the cooling settings, and the unit will cool. Okay, so that's, if we're talking controllers, our FETs, that's how the FETs work. And that's why the FETs are important. The FETs can take obviously a temperature and humidity sensor from inside the room, and the FETs can give us that information over the ISG and internet gateway. So, a third-party installation, if somebody's using, a rehouse system or Nest controls or whatever, that's all great. They can make it work beautifully, but it doesn't give us the opportunity to have that information back over our service wall. Okay. All right. So I hope all that makes sense. How to hook up a third party, just a basic third party control set to our WPMs. Very easy. Just a twin, a low voltage twin from point A to point B, and it puts us into basically an on mode. Okay. What you will note then, if I go back to the WPM wiring. Okay. So that X113 gave us, it was the mode changing from the actuator manifold module. There aren't any extra terminals just to put extra thermostats in. Like, you can't go and buy 3 Siemens thermostats and wire them into our WPM to bring on the heating circuit pumps. It doesn't exist. So if somebody wants to run a system in that manner, what they would have to do would be get your Siemens stats all through your house or whatever you want to do. You control all your actuators and you control your pumps, just like how you may do it with relays or a relay module, and then just send us a signal to stop and start the whole system. Simple as that. Okay. You cannot effectively control extra pumping circuits or mixers via third-party controls. You can't do it. We have to control those with our FETs. However, here's an interesting point. We can, if you have a system and you were doing, you just had a basic Siemens control or an Auspex or a Rehow zone actuator module in the house, and you send us that signal to stop and start, we still can run our system on the heat curve and we can control the temperature of the water going at you. So quite often, people will have thermostats and they will want us to control this whole manifold, or they will want to control manifolds. So what we say is, okay, perfect. You control the pumps, we'll control the temperature. So we'll put our sensors into heating circuit 2 and heating circuit 3, and we can control the mixers, and we can have the mixer sitting there in position with the buffer tank at the temp ready to go, and you can just turn on the pump when you want water going to that particular circuit. You do that with your third-party system. You can do that to your heart's content. It is fine. It is absolutely fine. So that's basic integration between a third-party module and our unit through that X113. X113 configure. So that's how to do it there. We can pass on all the information. Yes. Okay. So just to, I've covered this multiple times. We'll just show people how that mixer works for anyone that hasn't been in it. Obviously, there's our direct circuit, just going straight from the buffer tank via a manifold. That might be 50 degrees. And here's our mixer circuit with a mixer there. Once it gets to a temperature in that circuit, it will use this little mixer motor and divert the water coming back on the return. So we can have a colder temperature here than we can here. We cannot, however, have a colder temperature here than here. So that's the point I was making. So we cannot have circuit 1 at a colder temperature than circuit 2. Make that point because knowing what to set up on your individual heating circuits is important. Heating circuit 1 is unmixed. So it's just whatever is coming out of that buffer tank is heating circuit 1. Okay. I did cover this in a previous one, but I was showing how our mixer kits and manifolds can all pop together on a nice little manifold set that we do. There's our mixers. There's our unmixed pump. There's our mixed motor, and we sell the manifold set. So for the people that missed out on some of the components presentations, these are all components that we sell. So if you're wondering why your product material list might have all these interesting little part numbers on them, a lot of them are installation components. So you can have one flow and return going back to the buffer tank, and all your pumps nice and neatly mount on this manifold set that's already already pre-made, and you can do that to do up to 3 pump sets. Okay, FET, it's a little blurry. I didn't realise. FET screen 1. I'm just going to go through the different screens on the FET. Okay, so the FET being the indoor control, of course. Okay, so the FET, firstly on the left here, will jump between the room temperature and the humidity. So that'll just rotate back and forth. You'll notice the actual FET, the layout, is exactly the same as the heat pump manager. The FET, the heat pump manager controller is called an FES. The room controller is called an FET. They are probably the same, similar units with different software loaded up into them. That's the extent of it. So you can look at the outdoor temp. You can look at the indoor temp. You'll have the time and everything set. When you're setting the time, if you've got 5 circuits, 5 FETs, you in fact have to set the time and date once out in the heat pump manager, and it'll transfer that data to all of the FETs. So you don't have to go through each and every individual FET and set up all the time and the date and all the characteristics. You can do it all, in fact, from the WPM, everything from the WPM. Okay. So that's screen 1. It'll show your time, your date, your temperature, and bits and pieces, outdoor temperature. Once we get to screen 2, we can actually look at the domestic hot water temperature. Okay. So you can see what the current domestic hot water temperature is if domestic hot water has been attached to that system. If it isn't there, it will not show it. Okay. Screen 3, eco. So eco mode. So this screen allows you. So there's basically 2 temperature settings. We use a comfort setting and an eco setting. Comfort setting normally you'll set for 21 degrees or something, and eco you might drop back down to 18 or 19. Remembering they're a hydronic system. They're not a ducted system, which is just automatic. Capacity on demand. Be away all day, get home, turn the ducted on flat out, and it runs and heats the room from your 14 degrees up to your 21 in an hour or something like that. These are designed to run. They're designed to run looking at the outdoor temperature and just come on by themselves, go off by themselves, and just sort of modulate between 2 temperatures that you set, your comfort and your eco. This screen, however, gives you the chance to just lock it onto its eco mode for a select period of time. So you would use the dial and you'll say, all right, I'm going away for 2 weeks. Let's just turn my dial and set 14 days on my eco. Okay, bang. The thing is just locked onto its eco settings for its 14 days, and away you go. Screen 4. Okay, the comfort temperature. So the comfort temperature literally is the opposite of the eco. It is the comfort. It's the normal daytime temperature. You can just turn that up and down per heating circuit. Okay. Screen 5, the settings. So you can turn the dial, unlock that little padlock, which takes you into the settings mode. The settings mode gives you options like sensor calibration. So you can calibrate the actual readout on the room. You can see what circuit that FET is allocated to. You can also set your schedule. So if you've got a job, let's go back up with, you've got your WPM, your WPE, you've got 4 mixed circuits. That could be your master room, your living, guest. You can set a different schedule for the master, different schedule for the living at different water flow temperatures, all sorts of things. You've got a lot of specialty setting you can do per heating circuit. Remembering your upstairs circuit, you might want radiators. You might wanting them all run at 50 degrees, and you might want everything else run at might have an extension. And you might only want 30-degree water running through the floor in the extension because it's been so well built that any high water, and you can't control the temperature. Any high water temp, you can't control the room temperature. So that gives us complete control per heating circuit of how we do. So to summarize that, we can do different temperatures per heating circuit, high temp, low temp. We can do dew point managed control within that heating circuit. We can have a difference between circuits. Of course, we don't have to do one is all. We can do them differently for each circuit. And you can do fan coil unit. That gives us fan coil operation or possibility where we can just come out of the buffer tank with, you know, a pump set going up to 1 or 2 or 3 or 4 fan coil units, whatever it may be, you can be done. Looking at flow rates and capacities and all sorts of things. Now, we help out with a lot of this design, of course. You know, we draw schematics for every job. We're happy to, you know, to do a customized schematic if it's called for. It's just getting an understanding of what our system can do. A WPM and a WPE, there's a lot of function between the two of them, but that does not extend into actuator control. We don't do actuator control. So if someone said to me, I've got one heating pump circuit 1, that one there, and it's going to 2 sections of the house, and I want to control them separately, I'd say, okay, you can't do it with our control set, but you can do it with a third party now, and you can integrate it back to our control set. All those things are better off being thought about before. Of course, it's always the way. Because what we would also always say would be just run another flow and return and put it on another pump set, because then you've got 100% control, or just go full third party control. You know, that can be done. And just give us the cues of when you want, you know, what temperature, of when you want to start and stop. Okay. So we've looked at the FET. All this is available information-wise in the product data finder. Okay, so everything I'm pointing to, I'll just jump on there now and just give everyone just another look. Sorry. Don't forget, everyone, just pop down any questions that you may have just in all this too, because at the end we just want to sort of be able to get through some questions. Okay, sorry, I'm just looking for the product data finder here. Oh, got it. Okay, so that screen should come up. Okay. So this is the toolbox that, you know, I keep referring to and I'll keep coming back to. Sorry, I'll just get to the right script. Toolbox. So all this information I'm showing about the FET, about the WPM, about everything is available in our Stiebel Eltron toolbox, which for those who haven't been part of my previous presentations, this link here will do it. It is a publicly available resource. So what I would do, I'll get onto the product data finder. Coming via Germany, sorry. And we would pop in the FET, of course, and in the FET, we would bring up the remote controller. And we would find all of the little pictures I just brought up. We would find all the documentation about how that FET works. We've got a complete installation manual. It is all there. The notification list. So when a customer has a fault, which is be a high level fault and the system shuts down, it will show as a notification on the FETs, and the notification list can just be accessed, and you can see what that actual fault is. It is so much better going to site knowing roughly what that fault could be than trying to go there blind. So much better. Okay, where are we up to? All right, I'll just jump back to the other screen. Okay, so back to sort of controllers, okay, and levels of control. So what we've covered off so far is we can put a basic third-party module in, and we can just give us a off-on signal, easy. Option 2, we can just use our FETs, and we are controlling circuits only. And by circuits, I mean pump circuits, okay, with mixers, okay? That is the way to do it. If you want to put non-mixed circuits on there, you can in fact do it. It's just not a preferable way to do it at all, because you're taking a lot of the machine thinks it's doing one thing, but the results aren't showing the same thing. Okay, so let's go to the next level of control, about integration with other control sets. Okay, and the way to do that, the next, we'll jump up in levels of complexity. The next way to do it would be, I'll just bring up, hope that's up for everybody. The next way to do it is to use the low level inputs, okay? So we've got these two 0 to 10 volt inputs, X114 and X115, okay? They're 0 to 10 volts, okay? Meaning that we're giving them a signal of between 0 and 10 volts. Now what that means, if we, let's see if we can go to find the right slide. Okay, let's go start with X114. X114 is a mode selection. So we could use a third party zone module system. Third party zone module system, X114. And we could have it give us a 0 to 10 volt signal into X114, and it will give us mode selection. Because you must remember, the way that the unit selects its mode between heating and cooling, if it isn't forced into a mode, is via the outdoor sensor, the set points we put on the outdoor sensor. It's measuring the weather. Once it gets above a certain temperature for a bit amount of time, it switches over onto summer mode. And then we can choose another temperature if we want, or the same temperature to enable cooling. That is how the system normally will select its mode. However, we want to force it into a mode, we can via the 0 to 10 volt input. 1 to 5 volts, as you can see, is heating. 6 to 10 volts is cooling. Okay, very simple. Then we can look at X115. So X115 being the second 0 to 10 volt terminals that I was showing you. X115, we also can give it a 0 to 10 volt input. What we do is we set a buffer temperature at the 10 volt point, and we set a buffer temperature at the 1 volt point. And then when your controller is giving it a 0 to 10 volt variation, it's incrementally changing the buffer temperature, the set point. So we can choose a mode via low level control, and we can choose what temperature the set point in the buffer tank is via a 0 to 10 volt control. Now, for most BMS systems, that should be fairly easy. So, and that's what we're getting here. We're getting into the world, where's my controller? We're getting into the world of BMS, where we're saying, let's take these two 0 to 10 volt control inputs. We've got an external system. We don't want to use any of your FETs. We don't want to use any of that. We don't even want you controlling any of our pumps. We're going to do all that through our BMS. But we want to tell you what temperature we want that buffer tank when we want it. That is a, it is quite simple. Once again, it is quite simple to set up. Takes a lot of the, a lot of people have their control systems that they love already, and all they want us to do is give you a buffer tank of a particular temperature. Bang. That is how to do it. Okay, the next, I guess, more complex way of doing all this for people that are in that game is BMS control. Sorry, guys. I'll just jump into another screen here. Again. Where are you? Just waiting for that to come up. Is BMS control. Okay, so what I'm showing in this document here is our KNX BMS control. KNX is a language that is transmitting data to and from our WPM. So we can, via our ISG, which is our Internet Service Gateway. So our ISG is obviously connecting our heat pump manager to the network. We can integrate with somebody's BMS system that they're putting in their building. Let's get to the English. And we can talk to it through a chosen language. So we can do Modbus and we can do KNX. So for those that are into the control side of things, you may be doing jobs of a very high complexity where you're doing, multiple heating circuits. You want actuator control and everything. You want to control the pool. You want, you've got 4 or 5 fan coil units and you've got 4 heat pumps out there all connected to, it's all connected together. It's all one big system. And remember, this is something we can do, that this is what sets us apart from a lot of other brands, because we can do this. If somebody has an installation of that ilk, almost certainly there's going to be some BMS requirement. If there's not, fine, we can still control it all from the WPM. But if there is, within reason from the WPM, just with the functions I've showed you, if there is requirement for BMS integration, then an ISG gets installed, should be there anyway, and the KNX controller will actually go in and find our ISG through the network. It's a network control thing. Okay, I'm not going to go through everything here, but this just gives people a bit of an idea. So this gives 2-way data transfer all of a sudden. So someone could have a very fancy BMS system operating their whole house, their garage door, everything. And they're able to not only send cues to our heat pump system, but they can get them back from the management system, saying, what mode I'm in, what buffer temperature I am. There's read and there's write points, but you can see all this. You can see if, what's the operating status. I want to know what the flow temperature, the return temperature. You can bring all this into your BMS, and that BMS can then use that data. If it's sophisticated enough from a heating and cooling point of view, it can use that data to turn off and on circuits and control temperatures. So this is what we would consider the high level control, where you're actually got a network controlled BMS, be it Modbus or be it KNX, actually going in and taking control of our system through our ISG. Pretty cool. So, as you can see, we've jumped quite a long way. We've jumped from just using the old Siemens control that was already on the house because the elderly couple knew how to use it. And they just wanted to run our unit. We can do that all the way up to full BMS integration. And that's all coming through the WPM system, the same control system. Very, very, very expandable. Very expandable. What I'll just jump back into my presentation. Okay, one thing I wanted to talk about, I have covered it in another presentation, but we'll just go into it anyway because it is all to do with system control, is the SG ready function. Sorry, I'll just find, did see it. Sorry, guys. Oh, there it is. Okay, sorry, let's jump back into that. Just a slide was hidden on me. Okay, this is the energy management slide showing, and what I'm going to describe is we call it our SG ready function. Okay, so what SG ready is it's, if somebody has a PV system, we want to take as much advantage of that PV generation as possible. So what we will do is we will take a direct signal from the solar inverter, that being the solar inverter, with a programmable relay. That's important. So the solar inverter has to have some sort of brains in it itself. Now, most do. And there's greater levels of sophistication in this as well when it comes to some of the SMA product, which they talk through the ISG to our product. But this is what we would just call the low-level energy management system. So we will say, okay, that solar inverter's here generating electricity. It's nice day, batteries are charged. It's got all this excess PV, which a lot of solar systems have. What we would say is once it's generating over a certain amount, depending on the heat pump size and the solar size, of course, that can be predetermined, and we can assist with that. The solar inverter will close a relay. Okay. Now, what that does, we send a signal. Sorry, I'll just find the slide. It's in the wrong spot. We send a signal to, once again, X113. And we will close those contacts. Now, X113 can't be used for more than one function. And you would note that we were talking about it with third-party control. So, unfortunately, we can't use that for solar, energy management mode, and a third-party stat. We can only choose one function. So, be aware. We should pick up on that, though, when we're helping with design. Okay. So, once you put it into energy management mode, what that allows us to do is through the ISG, we can enable it. We can look at your buffer tank and any heating circuit that may be attached. Remember, we can have up to another 4 mixed circuits. And we can look at that room and we can say, all right, when we're producing all this excess solar PV, instead of the set point in the room being 22, let's make it 23. And instead of the domestic hot water temp being 50, let's make it 60. And the buffer tank as well. Remembering, we encourage storage of hot water. To store hot water in a buffer tank is significantly cheaper than buying a new Powerwall. Powerwalls are 14 kilowatts or something like that. We can store considerably more energy at a fraction of the price when we're using buffer tanks. So what we would do, we would have the solar inverter say, bang, I'm making all this power, turn on to energy management mode. Let's bring up the buffer tank temp. Let's bring up the room temps by a predetermined amount. Remember, you don't want to go too hot. I mean, you don't want the joint to be uncomfortable. You just want to make as much solar, as much opportunity for solar gain as possible. And you can obviously set your domestic hot water at a high rate. Now, that's a great feature. Now, the reason heating buffer, we ask if it's got a mixer because we don't want to send out too hot a water out of any particular circuit. So in this case, it knows it's got a mixer and it'll limit what you're able to do out of the circuits. What do you think of that? Pretty cool. Cooling, I just touched on this on every presentation almost. I'll just touch it on again. I think I may have already. By using an FET, remember, cooling, you must have an FET. Okay? On per circuit you want to cool with, up to 5, remember. So we want to cool, put the FET in, does its dew point management. We put a sensor, you need just another sensor on the measuring the temperature, going to that particular circuit, bang, you've got full dew point managed cooling as well as the heating circuit. Some people say, oh no, I don't want it. I want to buy cooling. If you've got cooling, you got it. If it's a nice little upsell for a customer, because you can, anyone that's considering doing floor cooling, do your research, go into it knowing what you're talking about. We're talking, a heating system, generally speaking, with standard 200 mil spacings, we can punch out, we don't want to go too hot, but, we're normally talking, 80 watts per square meter or something is our distribution, how much heat we can punch out. Cooling, with the same installation, you might be looking at 25 watts per square meter. Now, is 25 watts per square meter enough? Potentially not. I'm just looking at the time, guys. It's 2 o'clock. I'm actually going to start another presentation soon. I've basically finished. That's just some of the FES. That's just all the icons on the front of the FES and what they mean. This will all be available, obviously, like I've said. Cool. What I'll do, I'll just jump back in and I'll see if we've got any questions. Okay, here we go. I've got a couple. if we have a third-party system controlling all the circulating pumps from the buffer tank, do we set up area cooling on a dummy heating circuit? Would it be heating circuit 2? Would it be controlling all the circulating pumps? Not necessarily. Okay, sorry. I think I understand your question. If you have a third-party system controlling all your circulating pumps, and that's all of your circulating pumps, you got 3 circuits, and you want to do cooling, you will have to set up because you will only have 1 circuit in that system essentially. It's just called a single circuit system, be heating circuit 1, and we don't need mixers in that sense because we just run the whole buffer tank at dew point managed temperature. So what we'd do is you'd set up all your stats or your whatever you want. We would have to have 1 FET in the installation. It would be inside, purely used as a sensor for dew point management. So if you want to take that further, you've got a massive house, you've got heating circuits and actuators, and you got pumps going everywhere, and you want to be able to do cooling through that installation on a dew point managed mode, you've just got to have the 1 FET. Now, even if you're doing fan coil cooling, which is just fixed temperature, just say you're doing 3 zones of underfloor heating and some fan coils, you still got to have an FET. I know that doesn't make sense necessarily, but you have to have the FET to activate the cooling circuits. So just heating circuit 1 still, I can go into that in a bit more depth here if you've got an installation like that. Okay, Ronnie's asking, doing energy management with inverters that don't provide control relay can still be done with external current switch. Okay, excellent. So I was saying in my presentation, just in the presentation, that we need a switchable relay in the inverter. Ronnie's just making the point that there is another option. We can provide a solution for that. That's thank you, Ronnie. Great point. So assign it to heating circuit 1, even though there is no circulating pump. Correct. That's exactly right, Chris. Sign it to heating circuit 1. There doesn't have to be a circulating pump connected by WPM. Doesn't have to be. All we're going to do is manage the temperature in the buffer tank. Doesn't care whether there's a pump on it or not. Doesn't care. Okay, good questions. Really good questions. All right, guys. I just kept talking there. So I hope everyone's across everything I was saying. It's a good turnout. Thank you for everyone for coming again. Looks like what am I jumping into next? I think I'm talking heat curves and bits and pieces on my next one. But thank you again. Thanks everyone for sticking around, and I'll get stuck into my next one. 1:15. I think I'm coming on. Let me just check that. I think so. Yeah. Soon. All right. Thanks everyone. Cheers.